We've looked a few times at the global warming targets and emission gaps. There is a way to get a little bit deeper into one specific aspect of climate action, which is renewable energy, because basically the whole debate can be reduced to the energy intensity of the GDP and carbon intensity of the energy, because energy is basically 75% of the emissions, which includes buildings, transportation, agriculture, and industrial activities, and so on. So what are the renewable energy targets doing in terms of where they are headed and how they are able to reduce the emissions gaps in terms of where the emissions are headed and where they need to be headed for meeting the global warming target. So if we look at the two, we get a little bit more information. This is a report from IRENA, the International Renewable Energy Agency under the UN. So NDCs, or the nationally determined contributions by ambition and share of global emissions, we can look at the numbers, which are obviously very impressive. 194 NDCs submitted, 151 new or updated NDCs submitted, which was necessary because the original NDCs were not on target to meet the 2 degree C warming target. And remember, these are not mandatory. These are voluntary commitments. 91 NDCs indicate enhanced ambition. Already some have done that. So enhanced ambition 91, no clear indication 60, intended to submit NDCs 27, and no indication to submit 16 countries. So that amounts to 63% with enhanced ambition. Total greenhouse gas emissions covered as of 2018 is 46 gigatons CO2, and 18% have no clear indication, and 16% have intention to submit NDCs, and 3% have no indication of an intention to submit NDCs. But positive way of looking at it is this number is relatively small compared to the number of countries which have submitted and have even indicated enhanced ambition. Okay, countries of NDCs and other pledges, contribution of NDCs and other pledges to limiting global warming. So we look again at the greenhouse gas emissions. Business as usual by 2030. Before the first NDCs was at 59 gigatons CO2 equivalent. And the target 2.8, that would current policies, including the initial NDCs, would get us to 2.8 degrees C. So that's minus 5 gigatons CO2 equivalent reduction needed there. To get to 2.7 degrees C, we need latest NDTs that will only bring us down to 2.7 degrees C. So that's additional reduction of 5 gigatons CO2 equivalent. So you can see that we are nibbling into the total emissions expected by 2030. If NDCs and other mitigation pledges such as net zero are added, we reduce the emissions by another 2 gigatons, bringing the global warming target, global warming projection to 2.1 degrees C, and we need a whopping 23 gigatons CO2 equivalent on top of these, so 9, 11, so 35 total to come to the 1.5 degree C scenario. So you can think of that as the gap from the best NDCs and other mitigations in our pledges, including net zero. So 1.5 degree C scenario requires that we emit no more than 25, we bring it down by further 25 to basically 0 gigatons CO2 equivalent at at some point, right? So this is just looking at the emissions gaps in a different way. Global CO2 emissions abatement under IRENA's 1.5 degrees C scenario and required energy transition solutions. So projecting the emissions gaps onto required energy transitions you go again with the net annual emissions from 21 to where you need to be by, let's say, 2050. So planned energy scenarios contribute 36.5 gigaton CO2. Carbon emission abatement percentages are shown here. 1.5 degrees C scenario is shown here. So transport needs to go down by 8.4 gigaton CO2, buildings by 2.3, others like wildfires and leaks, etc., to reduce by 2.2 gigaton CO2. Power and heat plants, 13 gigaton CO2 reduction required, and industries need to reduce 11 gigaton CO2 by 2050 here, so that we end up with zero or negative emissions, which means we are not emitting more than we are taking down. So it's not that emissions themselves are zero. There are some unavoidable emissions like wildfires, for example, which have to be drawn down. So renewables would contribute 25%, power and direct uses. Energy conservation and efficiency would need to contribute 25%. So these are the abatements under the IRENA's 1.5 degree scenario and required energy transition solutions. Electrification in end-use sectors, 20%. So this goes for everything like electric vehicles. Carbon capture and sequestration and carbon capture and utilization industries would contribute 6% to get there, and BECCS, bioenergy and carbon capture and sequestration, and other carbon removal measures would have to add 14% to hit the target by 2050. Sectors covered in the updated nationally determined contributions include IPPU, which is industrial process and product use, which is 74% of the enhancement there. Waste, so that's 83% in terms of reducing wastes at various levels. Land use change and forestry, 84%. Agriculture, 85%. Energy, almost 100% of them rely on energy in updating their NDCs. So then the role of renewable energy in the energy transition can be looked at from 2018 to 2050 in terms of where we need to be to hit the 1.5 degree C target. So here we are, 378 exajoules total final energy consumption. So coal, total fraction of energy consumed. Coal, natural gas, renewable share in district heat is 9% here. 3% is the total district heat. Out of that is 9% renewable. Modern biomass, contribution of renewables is only 0.5%. Traditional biomass, oil, electricity, and of course other renewables contribute here 25% to electricity. We have to bring down the total energy consumption to 348 exajoules to meet this target, and we have to change the portfolio in a way that coal is down to 2% from 11%, natural gas to 4%, oil down to 4% from 37%, and modern biomass, hydrogen direct use. So renewable share of hydrogen is 66%. Renewable share in district heat would be 90% as opposed to 9% here. 4% other renewables, nuclear, natural gas, and so on have to be adding together to 51% of the electricity. So renewable share in electricity would be 90%. So it's all projections, but those are related to the emission pathways that would be needed to hit the 1.5 degree C target with 67% probability. Installed capacities in 2020, so global renewable power installed capacity in 2020 and 2030, future projections based on target versus IRENA's 1.5 degree C scenario, just in terms of renewable energy requirements. So installed terawatt capacity in 2020, the various contributions from hydropower, solar, combined concentrated solar power, wind onshore, wind offshore, geothermal, bioenergy, and others. So where we need it to be in terms of implementation targets, 2020 implementation targets, and where we need to be if we have to hit 1.5 degree C scenario. Obviously, we are way off, especially in terms of solar, hydropower, and wind onshore. Okay, so what does it mean? Obviously, that means we have a lot of work to do to get to the 1.5 degree C target, which seems almost impossible now, but there are narrow pathways by which it can still be accomplished. Total investments, if you look at in terms of technology in the planned energy scenarios and IRENA's 1.5 degree scenario for 2021 to 2050, here are the various portfolio members in terms of energy efficiency, renewables, electrification of heat and transportation and infrastructure, innovation, others like CCS and circular economy approaches, and fossil fuel and nuclear. So 3.3 trillion US dollars per year is the total investment in 2021 to 2050, with these percentages here to these broad categories, and where we need to be. This is the planned energy scenario, and this is where we need to be. So you can see this additional $33 trillion required, with $4.4 trillion US dollars per year. So instead of 98, we are at 131 if we want to hit this target, and the differences in the investments needed for energy efficiency, renewables, electrification, and others. So these have to be reduced from 44% down to 12% for hitting the 1.5 degree C target. How have the investments been flowing? International financial flows to developing countries in support of clean and renewable energy by technology. 2019 constant US dollars, billions of dollars. So you can see the numbers over here, 0 to 25. And if you look at the various members of the energy production, hydropower, solar, wind, geothermal, and other. So share of commitments to LDCs is included here in terms of percentages over this period, or these years. So this is the percentage share of commitments to LDCs. So there's been ups and downs, and now we are down here, less than 10 billion, that's the share of commitments to LDCs. But you can see that the flow of funds, financial flows to developing countries, has shown a drop since the peak in 2017. Obviously, various factors play into this, including progress, promise, return on investments, and so on. World Bank tends to report on the details of why those investments vary over time and why there may be a drop in the recent years, and we don't have data for the pandemic years, which may be quite dramatically lower as well. One has to watch out for that. So this is just a brief introduction to the fact that when we look at emissions gaps, and when we consider that 75% of the emissions come from the energy sector, we must pay special attention to where we are headed in terms of renewable energies and their contribution to the global warming targets, and where the gaps are in terms of investments needed and investments being made, and the flow of funds from the rich countries to poor countries to help them transition to renewable energy as well, right? Lots of challenges, but having these and having all the countries participating with NDCs and having plans to enhance their NDCs obviously is a optimistic message there, right?